Hello everyone, I'm back with another video. Today we're going to conduct a multivariate analysis of variance in SPSS. This test is used when we have two independent variables, both of which contain at least two levels and a series of dependent variables. A study was conducted to see the impact of social economic class, rich, middle, poor, and gender with males and females level on kindness and optimism using a sample of 60 people. The dependent variables here are kindness and optimism, which has been measured on the scale of 1 to 10 from lowest to highest. And the independent variables are socioeconomic class with 3 levels and gender with 2 groups. In this study, we want to see whether gender or socioeconomic status have an impact on the levels of kindness and optimism, and also the interaction of these two independent variables affect the kindness and optimism or not. Before doing the test, we need to check the assumptions. The first one is the sample size. 30 measurements for each level of independent variables have been measured. So the amount of measurements that is needed for each levels here is 20. So we check this assumption. And sample size would be equal to number of levels multiplied by the number of dependent variables. So we're good to go. We need to check multivariate normality, but there is no direct way to do that, and we can check this using some other options. So we first check for normality of kindness and optimism, the dependent variables, and I'll do that using analyze, descriptive statistics, and explore. Put kindness and optimism in dependent list box, and then on plots, uncheck stem and leaf, and check off normality plots with tests. So then we move down to the test of normality, and as you can see, we have Kolmogorov-Smirnov test and Shapiro-Wilk test. Normally, we only check Shapiro-Wilk results. So you can see that p-value for kindness here is 0.039, which is less than 0.05. And p-value for optimism is 0.057, which is greater than 0.05. So we would not assume normality for kindness. And also based on Kolmogorov-Smirnov, both of them are not met. Regression and then linear. We use linear regression function to calculate Mahalanobis distance, and so it doesn't matter which dependent variable to choose because we're not running the regression to find out the contribution of predictive variables to a dependent variable. And here I put economic into dependent box and optimism and kindness into independent, and then save and check off Mahalanobis and continue, then OK. So this is going to create a new variable and go to the table of residuals and residuals statistics, check the Mahal distance line, and as you can see, the max value here is 9.995, and that we know that the critical value for MANOVA's distance when you have two dependent variables is 13.82. So this value is less than 13.82. So we can assume that we met the assumptions of normality here. And so the third assumption is to check the linear relationship between each pair of dependent variables across each level of independent variable. So we'll do that using graphs. Go to Graphs, Legacy Dialogs, and Scatter Dot, and then choose Matrix Scatter, and here click on Define, and matrix variable would be kindness and optimism, and put gender and economic in rows box, and then okay. So here we're looking for an elliptical shapes, and it's like that for most of them, although for middle class and upper class women there are some points to consider, and also for put and middle class men. So move forward to the fourth assumption, and it is the test for multicollinearity, and go to Analyze, Correlate, and Bivariate. And now move kindness and optimism into variables, and then click OK. So in this table, we can see the correlation between two variables, which is 0.86, which is less than 0.9. So these variables are multicollinear. But we also want to make sure that they are related at a correlation of greater than 0.2, and so we met both of those assumptions. And now we're good to conduct the MANOVA test. So go to Analyze, General Linear Model, and Multivariate. Put gender and economic under fixed factors, and kindness and optimism under dependent variables. So then click on Plots and put economic in horizontal axis and gender in separate lines, and then add and continue. Then click on Post Hoc. We need to do post hoc just for economic because it has more than 2 levels. And now, since we have the equal number of cases for each level of economic, we use Tukey. But if we didn't have the equal number of cases for each level of economic status, then we could use Chiffre. So click on Continue and click EM means. Display means for economic, gender, and economic times gender. So then click Continue, and then Options. And now check Descriptive Statistics, Estimates of Effect Size, and Homogeneity Tests. Then and now click Continue, click OK, and then Continue. So now looking at the results, you can see we have 20 participants in each level of economic and 30 participants for each gender. Moving to the table of descriptive statistics, you can see the mean for each combination, and here the lowest mean is for kindness of middle class males at 4.9, and down here for optimism of middle class males is also lower at 5.3. So now moving down to the boxes of tests of equality of covariance matrices, and we can see p-value here is 0.576 and alpha here is 0.01, not 0.05. But either way, none is a significant result. In this case, since we don't have a statistically significant result, we've failed to reject the null and assume the covariance matrices of dependent variables are equal across groups. So moving on to multivariate tests, we did violate the first assumption for MANOVA. So we're gonna interpret place trace. If we didn't have violate the assumptions, then we could use we could interpret lambda. So anyway, for economic implies trace, the p-value is 0.169. By looking at the partial squared, that percentage of variance that explained in this value for economic is 5.7, which is not a statistically significant small. And also p-value for gender is 0.262, and its partial squared is 0.049, and it is not also statistically significant small. So it says that the combination of kindness and optimism by economic is not equal for all levels of economic, and also the combination of kindness and optimism differ by gender. And then we have the interaction for gender and economic. We can see that it is not statistically significant comparing with those two that we just mentioned, and it is 0.039 or 3.9%. For Levin's tests of equality of errors variances, we don't have significant result for kindness and optimism here. That says the error variance of the dependent variable is equal across groups. And in the next table, we have tests of between subjects effects. We were looking for significant findings here. If you look at the economic and each of kindness and optimism for that, we have a statistically significant result for optimism with p-value of 0.048, which is less than 0.05. And for gender, we have the same interpretation that we just did in the previous table. So move on to the next tables. You can see the confidence interval for gender, economic, and for the combination of these two. We have the post hoc test for economic. There is no statistically significant p-value for none of the results. Across all levels, the scales is growing for females, but for males, it has a drop for middle class people. But lowest scores for both are wealthy class, and the highest are the poor class. Looking at optimism for females, the same trend applies. For males also, we can see a slight difference here, that optimism of wealthy males is more than the optimism of wealthy females, and that's it. Thank you so much for watching this video. I hope you found this tutorial helpful, and I'll see you in the next video.